only one student is there, like you are only here.
No, I'll go with the sessions as well.
Okay.
Yeah, thanks.
So you are preparing for like you are a professional or you are like a student.
No, actually, I was a professional, but my contract has ended, so again I'm resigning.
Okay.
I'm searching for new job now.
Okay. What was your domain before?
Domain?
Yeah, like what in which area you used to work in?
Java Spring Boot. And,
So you are searching for the same thing.
yes, Rahul.
Correct.
And this session is for like the Java only, right? Like this is now is the data structures, but like
Correct.
come every
Sorry, come again, Karthik.
yeah, like here like you will be providing yeah you will be providing like marketing and like the training for the Java, right?
Our whole boot camp is all about that, but the this section which I am taking will be focusing on data structures only. In today's
Oh,
session, we'll be focusing on data structure only.
oh, okay, thanks.
Are you okay? Like, are you comfortable with data structure? Any data structure you want me to pick?
Yes, Rahul, I'm comfortable. Like, yeah,
So, do you know about recursion?
yeah, recursion is nothing but like loop, like it's a loop, right? So repeating, like repetition of any statement. Like if you want to, like, for example, if factorial program, if you want to write a factorial program, so we'll
Hmm.
use a recursion. And so in
Factor.
some cases,
Let's say what is the factorial of 4? Like mathematically, we write something like this, right? For exclamatory sign. This is 4 factorial. 4 factorial, the value of 4 factorial is
yeah, 4 into 3 into 2 into 1.
24, correct?
Yeah,
Okay. Similarly, for 5 factorial, it will be 120. So
yeah,
if I say write this factorial program in iterative fashion, how we can do it is that we can create some like the let's say the return type of the function is integer, the name of the function is in fact, and we are taking an input. And now what we can do we can calculate answer, like we can initialize answer uh, by 1, and we can run a loop for I starting from 1 till n. Okay, and every time I will be keep multiplying I, correct?
yes.
Okay. And by the end of the day I can return my answer. So this is in iterative fashion, okay, because we are writing loops. So how can we do the same using recursion? So see, 5 factorial is nothing but 5 multiplied by 4 factorial, correct? Correct, right? So if I want to write the recursive code of this factorial, what I can do is that in fact integer n, the same thing, the same definitions and all. Here what we can do, here we need to know, like, see, in recursive code, there are 3 more important steps. First step is to calculate or to know what is the base step. Okay. Second thing is that some operations, like there is a something known as recursive call. Okay. This is the second step. And third step is that some intuition or something, your own calculation. You need to know that when to put multiply, when to put addition. You need to understand those things as well. So, our base case is something like where we want to stop our recursive code. Let's say what I am saying in my recursive code, what will be happening because recursion is nothing a function calling itself. So 5 factorial is nothing but 5 multiplied by 4 factorial. Now 4 factorial is nothing but 4 multiplied by 3 factorial. Now 3's factorial is nothing but 3 multiplied by 2's factorial. Then 2's factorial is nothing but 2 multiplied by 1's factorial. 1's factorial is nothing but 1. So this is a very trivial step. That is, we know everyone knows that 1's factorial is 1. So if you encounter that, you can return if n equals to 1, then return 1. Else you can return n multiplied by factorial of n minus 1. Are you getting Karthik?
Yes, no,
Cool. Any doubts so far?
no doubt.
Mhm. So can you tell me the time complexity of the first code?
Time complexity, I don't remember exactly. Like long ago, like I have attended your sessions, so it might be like for everything. Like for example, in 10, so this will be 1 plus 1, 2, and you have said like how to calculate the time complexity at that time. So I have attended that session.
So let's do it again.
Yeah.
While attending the time complexity, our focus will be strictly on the loops because loops only can determine how much time complexity of our code will be. But in case of iterative code only, if our code is in the iterative fashion, we need to search for whom loops. Using loops or function calls. A function call, mostly function call won't be there. If it's a iterative code, then we need to look for what? Loops. So we got our loops over here. Correct. Now what we are doing inside that loop? We are doing a small arithmetic calculation. Correct. We are doing
Yes.
inside
Yes.
our loop, we are doing small arithmetic calculation, which means a small arithmetic calculation will be taking order of one time. But the thing is, how many times this arithmetic calculation is happening? N times, correct?
Yes.
So you'll be multiplying it n. So it's order of n
Mm.
time complexity.
So yeah. So like the first, so this will complete loop is order of n, and in between the loop there is one statement, right?
This is
So
constant. This is again a
okay.
constant, and this is again a constant. Okay. So
Okay.
what we can do is that we can say it's order of n plus order of 1 plus order of 1. But the thing
Uh,
is, we sorry, this is order of 1. Mm. So we take the largest among everything. So this is the largest, right? So I have a like I usually give this example. Let's say you went to buy like a car. Okay, the car worth, let's say, 10 lakhs. While going, uh, you took some Uber, which costed you 1K. After buying that car, you went to some good restaurant and had a good food of 2K. Now, when you will come back or in the evening, your friend will ask how much your car costed. Will you tell 1 lakh, 10 lakh, 3,000, or you will just tell like 10 lakh?
10 lakhs. 10
Correct.
lakhs.
Like the most uh, dominating factor will be picking up. Okay. Okay. But the thing is here. in recursive code, how to calculate time complexity? Is there any loops over here?
No, no loops.
No loops, right? So this is how we calculate time complexity. See, so what we will be saying, the time complexity with an input is equals to how, what kind of operation we are doing? We are doing some multiplication operation only, right? Some multiplication
Yeah,
operation only we are doing on fact of n minus 1. I am saying, see, this fact with n input is taking t of n, which is nothing but time complexity that will be occurred by t of n minus 1 plus some constant value. What I'm saying is that this fact with n input, let's say the time complexity is t of n, but the fact, this factorial function with n minus 1 input, let's say this is time complexity as well as we are doing some constant work. Okay, are you understanding how I have written this thing?
yeah. Actually, yeah, I have one doubt, Rahul. So t of n minus one, that is like complexity of it's not calculated yet, right? So we just assuming that it is a
Correct,
t of n minus one.
correct.
Uh,
Now, what is t of n minus 1? T of n minus 2 plus constant. Can I say this? Correct, right? Because see, you need to figure out some relation. Here n minus 1. So here n minus 1, so here n minus 2.
mhm.
For t
Yeah.
of n minus
Uh,
2, yeah, please ask.
Go ahead, go ahead. I'll ask it.
Yeah, t of n minus 3 plus constant. So if you write it down like t of n is nothing but this is t of, you can say, so basically, if we go over here, if I say t of n, sorry, t of 2 equals to t of 1 plus some constant it will be, and for t of 1 it will be some constant directly because with one input I know that will be the value, like, so we can directly return from there, right? Okay. Now what I will be doing, I will be replacing t of n minus 1 with this guy. Okay. So what will be the
Uh,
value? T of n equals to t of n minus 2 plus order of 1
okay.
plus constant. Correct?
Mm, yeah, yes, yes.
Now if I replace this guy, it will be t of n minus 3 plus constant, and in there outside this guy will be there and this guy will be there. So let me just simplify so far. It's nothing but t of n minus 3 plus 3 multiplied by constant. Fine.
Okay. Yeah.
So if you see a pattern that here it was 2, here was only 2 constant, here it is 3, here 3 constant. So if I go down, that is if I say t of n minus n minus 1, then it will be n minus 1 multiplied by constant.
Mhm.
So, correct?
Yes, yes.
So it's nothing but t of 1 only. See,
Mm,
n minus of n minus 1, if you open up the and cancel, it's 1 only, correct?
yes.
So t of 1 plus n minus 1 multiplied by constant. Now t of 1, what is the value? We know, right? It's constant directly. So constant multiplied plus. n minus 1 multiplied by order of n. So it's nothing but, can I add it up? N multiplied by constant, which is nothing but order of n only, which means t of n is order of n only. So this is how we uh, simplify the recursive. We find the time complexity in the recursive code, right? So what you have seen is that both recursive and iterative time complexity is same. Basically, the powers are always same, but can you tell what will be the space complexity over here?
I have no idea.
Okay, okay, let's forget about. Let's solve some problems. Multiply a and b. Okay, we want to multiply a and b, but recursively. You can't use multiplication symbol to do it. You need to do it recursively. Can you give it a try?
Sorry, using recursive, like,
Yeah,
yeah, and it,
you can't. Don't use
okay.
multiplication. Yeah. Uh, Hello.
Yes, Ram.
Yeah. So have you thought of anything
Sorry, I didn't get you.
like you got some any idea like how you can solve?
Oh, don't like, oh, for multiplying without using the,
Yeah,
okay, by using the recursion.
yeah, recursion or yeah, recursion. Mhm.
Okay.
So
Hi.
see, 2 multiplied by 3 is 6, correct? So we can say 2 times 3 or 3 times 2 is equals to 6, correct? 2 times 3 if we add 2 3 times, or even if we add 3 2 times, we are going to get 6. Can you use this concept to get the answer? Yeah, you wanted to say something?
Hello.
Hello, hello.
Hi. Like we can use shifting operation, right?
Shifting operation, how?
Like those angular symbols, like left shift and right shift operators.
Okay, how? Let's
Like
say
we can, yeah.
uh, A is 2. So,
Then A, then double, yeah. Then we
yeah,
can like
I'm just waiting
shift it to the
binary.
right, right? Yes.
A, you want to shift it to right side.
Right. Yes.
By how many times?
Actually, like that's what we use, right? If like we want to multiply the number by two, then we can write two instead, right? We can write the number a double
No, no, no,
operator
no.
and then two,
no.
right?
I have just given the number randomly over here. It can be 5 multiplied by 7 as well.
Okay, so any two numbers.
Yeah, any two numbers.
Oh, then oh, then we can use addition. Yeah, we can just
How?
add five 7 times, right? That will
How?
solve.
Like using for loop?
Yeah, using for loop, we can
No,
do
no,
that.
no.
Yeah, yeah,
You can't use for loop because we need to write recursive code.
yeah.
Okay. Yeah,
Okay,
definitely you can do that. Something like answer equals to 0. You can
yeah,
say for I want to be answer plus equals to a return answer. Correct. This is correct, right?
yeah.
But can you do the same thing in recursive?
Like we can use that same method here, right? Instead of that a,
Correct,
that
correct.
answer.
Basically,
Yeah.
we added a b number of times. So what we are going to say is that let's say the value of a is 5, b value is 3. So what we are going to say? Okay, in my answer it's 0. I will add basically something like multiply 5 3. Okay. So what I'm going to say? Okay, it means 5 plus multiply of 5 2. The answer we will be getting from here if we add it and with 5 we are going to get answer for this guy. Correct or not? From here what are we are going to say? 5 plus multiply of 5 and 1. The answer we are going to get from here, if we add it with 5, we are going to get answer for this one. Now, what I am going to do over here, 5 plus multiply or let's say if your b is 1, if your b is 1, if the b's value is 1, then you definitely know that what will be the answer for this guy. Here b was not 1, that's why you don't know the answer. Here it was 3, you don't know the answer. But if it is 1, then you definitely know the answer. That is value will be nothing but your a, the value of a only, that is 5. Correct? So if b equals to 1, then return a. Else, what will be written is a plus multiply a comma b minus 1. Correct? Do you agree with me?
Yeah, yes, yes, sir. Um,
Great, great. Okay. Uh, so are you guys comfortable with trees? Are you guys comfortable? Do you know what trees like binary tree, something like this? Mm, okay, let me teach you something different then. Um, Let me ask you some different question then. Mm, okay, these are the very common interview related question. Okay, so just see 1, 3, 5, 7, 9, 2, 1. I'm giving you this array. What you can see, what you can get insights from this array. Can you tell me what kind of insights you are getting from this 2D array? Hi guys, can you see our rows are sorted? Yes, please. Can you see our rows are sorted?
yes, yes.
Can you see our columns are sorted? Okay. Now I will be giving you this 2D array as well as some k, some integer k, maybe let's say 9. You need to find out if 9 is present in this array or not. How you will be doing this question? Guys, please respond. How will be what you guys are thinking, like how we can solve this question? I'm waiting for your responses.
Yeah,
If
like actually we have to use like two, three loops, I think. One loop is for this first row. Second is for, is that right, Rahul?
No, no, we don't need to use like. Do you mean for every row we need to create separate loop?
Yes, I think that way, but it might be in other way as well. So I don't know.
Correct, correct, correct. So basically, if I want to traverse a 2D array, how many loops we need?
Uh, it's two.
Two, right? Two,
Yeah.
something like this. For I 0 to number of rows, and for j 0 to number of columns. Now I can get my uh, element with something like this, correct?
It's similar to them. It's a matrix problem. Right?
Correct, correct. So using this, we can do that, right?
Yes.
Now, if I give you some element and I ask you to search if that element is present in my 2D array or a matrix, uh, then how we can do it?
Can you repeat the question? Rahul?
2D, yeah, sure. So we have a 2D array, okay? Let's say something like this. Let me just give you. It's a boolean. Find in 2D array, okay? And we are given uh, basically 2D array, fine. Now we are also given how many rows are there in my 2D array, how many columns are there in my 2D array, fine. Now, as well as we will be given an integer k. We need to see, we need to find, we need to tell if element k is present in my 2D array or not. As if my value of k is 9, then we need to return true because it's present. If my k value is 17, then we need to return false as it's not present in my 2D array.
Mm.
So how we can do it?
Okay. So like it just like, well, we have to. This is a complete array, or like it's a single digit around.
A complete array means
Like this is a int array. Like you have given two index like that. Two, like this one, right? What, as as you mentioned, it as an element, right? Array of, for example, I of j, like in this way, or else just like it's a empty one. Like
no, no,
you are
it's
passing.
not an empty array. It's already filled up array.
Oh,
Okay, it's already populated.
okay. So and we have to check with this one, right? The rows and columns. And if we have to take this array and we have to check with this row and column number, and then we have to compare with this k, and then if it is true, then if it matches, then it will be.
Correct. So what you are saying is that you will be checking row by row. That is, you will be searching in this row if your k is present one by one. Then you will be coming over here. Again, you will be checking one by one. You will be coming here. Again, you will be checking one by one. Correct? Are you going to do something like this, or you want you meant something different.
Actually,
You know how to print this array, right? Like how to
y-
traverse this to the array.
yes, yes.
Okay? So it will be something like rows minus one, it will be 0, 2, number of columns minus one, and yeah, this thing. Now, if you do if that at that position, if it is equals to k, then return true. And otherwise, when you are coming out of this for loop, then return false because you are not able to hit this return statement. That's why you're coming out of this for loop, outer for loop, after searching each and every indexes. That that what you are returning false. Are you getting my point?
Yes, Rahul, yes.
Yeah, yeah. So, what do you think? Like, so will this work? It will work, right? But the point is, here our rows are sorted. Here our columns are sorted. Can we do something different? So let me tell you what we can do. We can keep a pointer over here. Okay. Now, as my rows are sorted and columns are also sorted, so our target, let's say, is 9. So when I'm pointing to this guy, 5, can I say anything on the left of this guy? Anything on the left of this guy? Uh, Anything on the left of this guy will be less than 5 only, as our row is sorted. Anything left on the left side of 5 will be less than 5 only. It means I cannot find my 9 on the left side. Can I say this? So can I eliminate this whole row? Okay, after eliminating this whole row, I can come over here. Okay, now I want 9. I am pointing to 12. Our columns are sorted. So if I go down, I won't be able to find 9 because my columns are also sorted. So can I eliminate this guy? Now I am currently pointing over here. So we found our 9. Okay. So isn't it much better approach than what we are doing using two loops? Now if I want to search if 17 is present, how we can do? Again, we'll be starting from here. As 17 is greater than 5, so we can eliminate this entire row. But we can come over here. It's 12. Again, it's 17, so it won't be present in this row. We can eliminate. So we are coming over here. So it's greater than 17. That's why 17 can be present on the left side, but it won't be present anywhere below it. And there is no element. So we can move over here. So it's 20. It's greater than 17. So 17 can be present on the left side, but it can't present in below of it. So we moved here. So we are pointing to 15, and we want to find 17. 17 can't be found on the left side of 15 because it's smaller than 17, right? It will be below, it can be below, but as there are no elements, we are going out of the boundary. That's why we can return false because we crossed our boundary but haven't found our 17 yet. So we can say 17 is not present. Are you getting what we are trying to do? Karthik, you got what we did, like, or it was like a little bit heavy to consume. If my array wouldn't be sorted, I would have went with this approach only, method one. But as my arrays 2D array is row wise sorted and column wise sorted, I took something different approach because I took the advantage of things being sorted. Like in dictionary, when we know it is sorted in the lexicographic manner, correct? That's why we randomly open any page and we do a binary search. That is, if I want to search something which is present, which is starting with the, let's say, elephant. I want to search for the word elephant, and randomly I will, if I open on the page where words with the, like, alphabet P is starting. Let's say I opened a page randomly where words with P is the, like, P is the first character, where P is the first character. Then I know that definitely if I want to search for elephant, if I want to search for elephant, I want to see what is the meaning of elephant. I want to read more about it. Then definitely I know I open a page where P is the first character. It means if I want to go to the elephant, I want to search on the left side of the dictionary only. I can't, if I search on the right side, it will be meaningless. It will be a time waste. Okay. How I know that? Because dictionary is lexicographically sorted. Here also things were sorted. That's why we could uh, like take things. Like we went with this approach. Otherwise, we would have went with that approach only. Yeah, Karthik, you are asking something.
No, no, nothing, nothing.
Okay, you understood. You want me to repeat or something? See, let's say if I just modify the question, if I say now 157. Uh, okay, what was the time complexity of our method one? Here, what is the time complexity? It will be, if let's say number of rows is n or columns in n, time complexity will be order of n multiplied by n. Correct? Okay. Now the point is our row is sorted, but our columns are not sorted. Now what we can do? Do you know about binary search? Do you know about binary search?
Yes, Rahul. Like we'll be dividing like elements into the off, like by taking the middle element, and we'll be
Uh,
searching right, so to the right and to the left.
okay, okay. So what is the time complexity of a binary search?
Okay.
If my search
No.
space is n, if my search space is n, then what will be the time complexity? It will be order of log n base 2. Okay. Now, what we can do over here is that if my rows are sorted but columns are not sorted, so I can't move with the optimized approach that I have told you over here. Here I have to go row by row only. But here, as my rows are sorted, I can apply directly binary search in my row. So this row will be taken log of like how many guys are there? M guys are there because in my this is my row and in this row m elements are there. It will be log m base 2. Here also log m base 2. So it will be order of n multiplied by log m base 2. Fine. Cool, Karthik. You have any doubts from today's session? If you have any doubt, if like anything, any, just ask. Feel free to ask. I will tell.
Like do you have any question like any questions like kind of this?
Like the list of questions.
Yeah, list of questions for
Yeah,
this.
yeah, I have. I have. Can you ping me in the like Slack? I will
Yeah,
share.
sure. Yeah, sure.
Okay. Thanks, Karthik.
Yeah, that's right.
Yeah, sure. Hope you learned something new.
Yeah,
Okay. Great. Good night, Karthik.
yeah. Thank you. Good. Good.